Hi guys, this is Michael from Bridge Channel, and today we're going to talk about AP Physics Unit 1. Let's dive in. And this AP Physics might be a little bit overlapping with the AP Physics C. It's just a little bit. That's how our school class worked. So yeah, it's based on my notes from that class. So it's going to be a little bit overlapping with AP Physics C. So AP Physics starts with the science inquiry. I don't know what it means, but it just starts with science inquiry. So the first big assumptions. Oh yeah, science inquiry means the two huge assumptions that you have. So the first biggest assumption would be that universe is consistent and is predictable. And the second assumption is that through study, we can understand the behavior of this universe. Now we're going to talk about the hypothesis, theory, and law. Hypothesis is some explanation that is not tested. When it gets tested and when it's accepted, it turns into theory. And theory means the explanation of observable facts. And law is just a collection of observations. Now, that's the difference between the theory and law. Now let's move on to the model. In physics, we call models an abstract construct or idea that is simplified view of reality. We can just simply say as simulation. So in models, there are a bunch of kinds of models, but there's like a physical model, fictional model, descriptive model, and mathematical model. So fictional model, or something like a useful lies we call. And those useful lies are something like Bohr's atom model. So Bohr's atom model are not true. They're not actually close with how actual atoms look like. But it is useful since we can refer how the atom looks like from that. And the atom models that we use nowadays developed from Bohr's atom model, which we can also say that it was useful. That's why we call it as a useful lie. And the descriptive models would be the textbook. The mathematical model will be the formula, plotting, and other stuff. So now let's go into actual physics. In this unit, we're going to talk about the velocity and the displacement. So, this is a description about displacement. Every measurement of position, distance, speed must be made with respect to the reference point. Oh, my bad. It's not about displacement. It's just a general measuring tool. Every measurement of position, distance, speed must be made with respect to reference frame. This means that there should be a certain point that you use as a standard. You use as a spot to determine whether this is positive or negative. For example, when you're standing on the floor and you throw the ball upways, you're throwing the ball up, and if you're trying to say that when the ball goes up, it's going to be a plus, then it's automatically going to be when the ball falls down, it's going to be a negative. That's what this means. It's just simply saying that you need to decide which part you're going to put as plus and which part you're going to put as minus. Now let's talk about the difference between distance and displacement. So we use distance when we measure a speed, and we use displacement when we measure velocity. So distance is a scalar value. It means that it doesn't have a direction. And the definition of distance is how far object traveled. It doesn't matter if the object goes 50 meters and comes back 50 meters. It's total 100 meters since the object travels 100 meter. But for displacement, it's a little bit different. Displacement is a vector value, which means that it does have a magnitude and also a direction. So displacement usually talks about how far the object is from the starting point. So the very first example that I talked about as a speed, which was when someone goes 50 meters and comes back 50 meters, the distance would be 100 meters, but the displacement would be 0 because it didn't move from the starting point. It's starting at the same starting point, which means that it didn't move according to a vector point of view. So this is a graph of uh, distance and time. and uh, it's about velocity. I mean, it's about displacement and time because it has negative quantity too. So when you start from 0 and it goes up 2 meters, it increases from 2 meter to 3 meter, we can know that it's moving away. When it decreases from 3 meter to negative meters, we can know that it's moving closer. And when the slope is stiff, it means it's faster. When the slope is really low, we can know that it's slower. Let's talk about the graphs. So the slope of the displacement graph is velocity, as I talked about like a few seconds ago. And the slope of velocity would be the acceleration, because acceleration basically talks about how much your velocity increases every second. And acceleration is also a vector quantity. And the area under the velocity graph will tell you the displacement, because, so for example, if there's a graph like this and the velocity increases from 0 to 1 meter, and 1 meters per second, and to 1 second, this part would be the displacement. So the average speed is a little bit different from velocity, but average speed means distance divided by time, and the average velocity means displacement divided by time. Average acceleration is the change of velocity divided by time, and we can infer whether the object is going slower or faster or turning around or example. And the formulas that we're going to use in this unit will be these ones. These will be called as kinematic motion formulas. And the first formula, velocity, I mean the average velocity. Average velocity is uh, delta x, which is the displacement, divided by delta time, which would be the time, which would be the difference in time. Acceleration would be the delta x divided by delta time divided by delta time again. Velocity would be the limit of when the delta time goes. I mean, this is the instantaneous velocity. Instantaneous velocity would be the limit of when t approaches 0, delta x divided by delta t. And the acceleration would be dividing that with delta t. And the g, which we refer as gravity, is 9.80 meters per second square, which we call as just g. Or sometimes in your AP Physics exam, they usually tell you as a 10.0 meters per second square. You should always read the question for this. And these are the other formulas that we need to know. So the velocity will be the starting velocity plus acceleration times time. Your location, your displacement would be the starting location plus the initial velocity times t plus 1 over at squared. The This is another formula that you use by using another formula that you get by using this one. And the average velocity is the final velocity plus instantaneous, not instantaneous, final velocity plus initial velocity divided by 2. I'll just be a little bit more specific about how we get this equation. So xo is the starting point. If you're throwing a ball and you're throwing a ball from an airplane, then your starting point will be like, I don't know, like 3,000 feet up sky. And then initial velocity plus time means that how much you were going before you start accelerating. So if you were going in 2 meters per second for 2 seconds, then you already went 4 meters. And then 1 over at squared equals how many displacement you moved when starting acceleration. If you look at the velocity graph, it's gonna look like something like this, right? It's gonna be 0, let's say 20 meters per second. It took 2 seconds. So acceleration would be 10 meters per second. And then we're trying to get this part because I said the area under the velocity graph would be the displacement. So using simple geometry, it's going to be 2 times 20 divided by 1, which should be, that's going to be the displacement. But if you look at this, 2 is the time, right? 20 is time times a, right? Because I said the velocity over here is VO plus AT, but initial velocity was 0. So if you change this formula, it's going to be 1 half times AT squared. And that's how this comes out. Yep, that was all for AP Physics Unit 1. Thank you for listening, and I'll come back with AP Physics Unit 2 next time.